Hello friends, I am Dr. Amrutkar, Assistant Professor in Department of Statistics, KRT Arts, BH Commerce and AM Science College, which is popularly known as KTHM College, Nashik. First of all, welcome to the M.Sc Statistics Part 2 class. I am going to teach you Paper 2 Bayesian Inference. Friends, we have now learned about two approaches of statistical inference, which is subjective, which is also known as Bayesian, and frequentist. Both approaches allow one to evaluate evidence about competing hypotheses. In this lecture, we will review and compare these two approaches. So first one is frequentist, which is treat the parameter as fixed, or you can say that it is the deterministic inference. Means in this case, parameter specifying the conditional distribution of the data. That means the frequentist approaches only uses conditional distributions of the data given specific hypothesis. The presumption is that some hypothesis is true and that the observed data is sampled from that distribution. In particular, the frequentist approach does not depend on the subjective prior, that means that which is not depend on the before any knowledge about that parameter, and that may vary from one investigator to another. And another one is the Bayesian inference. Bayesian treats the parameter as random. In the Bayesian inference, we use the Bayes theorem to combine prior with data to obtain a posterior distribution on the parameter. That means if your parameter is random, that means the parameter has some distribution, and which is also known as the prior because it is the some prior knowledge about that parameter, and using this prior knowledge we find the distribution of that data by using this prior knowledge, and that distribution is known as posterior distribution. That means uncertainty in estimate is quantified through the posterior distribution. Means Bayesian approach models uncertainty by a probability distribution over hypothesis. Is that clear? Means in frequentist inference, the conditional distribution of data given specific hypothesis. But in Bayesian approach, uncertainty by probability distribution over hypothesis. One's ability to make inferences depends on one's degree of confidence in the chosen prior, and the robustness of the finding to alternate prior distribution may be relevant and important in the Bayesian inference. So we firstly differentiate between this frequentist and Bayesian inference. So in the frequentist distribution must be there is the no prior or posterior distribution we will be find. Means in frequentist inference never uses or gives the probability of hypothesis. Also, frequency inference depends on the likelihood for both observed and unobserved data. It does not require a prior knowledge in frequency inference. Frequency inference dominated statistical practice during the 20th century. This frequency inference tends to less computationality intensive. But in Bayesian inference uses probabilities for both hypothesis and data, and which depends on the prior and likelihood of observed data. It requires one to know or construct a subjective prior. It may be computationally intensive due to integration over many parameters. These are the some basic difference between the frequentist and Bayesian inference. So, before starting the Bayesian inference, we will see the some basic concepts, and first of all, we will go to the Bayes formula. So, here we suppose that there are two events A and B are the two events, and we learn the Bayes formula perfectly abstract statement about conditional probabilities of event. That means that probability of A given B is equal to probability of B given A into probability of A divided by probability of B. But in Bayesian inference, it reinterpreting the event in Bayes formula, that is probability of H given D, which is equal to probability of D given H into probability of H divided by probability of D, where the H is a hypothesis and D is a data which may give evidence for or against H. That means hypothesis. Each term in Bayes formula has a name and role. That means probability of H is the probability that H is true before the data is considered, and probability of H given D is the probability that H is true after the data is considered, and the probability of D given H is the evidence about H provided by the data. Is that clear? And last one is this probability of D is the total probability of the data taking into account all possible hypotheses. If the prior and likelihood are known for all hypotheses, the Bayes formula computes the posterior exactly. Is that clear? Means if you know the prior as well as likelihood for the your considerable hypothesis, that case Bayes formula find the posterior distribution. For example, we roll a die randomly selected from a cup whose content you know. We call this deductive logic of probability theory, and it gives a direct way to compare hypotheses, draw conclusions, and make decisions. In most of the experiments, the prior probabilities on hypotheses are not known. In this case, our recourse is the art of statistical inference. We either make a prior or do our best using only the likelihood. That means we either use the Bayesian or Frequentist. The both case we get the same result. When we don't know the knowledge about prior distribution or prior probability. So further we see the generalized form of Bayes theorem. In the last slide, we will see the only for the two events. Here, we just see the generalized Bayes theorem, that is, if A1, A2, AK constitute a partition of sample space, yes, that means we partition the whole sample space in the K parts, where the probability of AI means probability of each partition is not equal to 0. That means there is some positive probability are there for I is equal to 1 to k. Suppose B is any other event in S such that probability of B is positive. Then probability of AI given B is equal to probability of B given AI into probability of AI divided by summation of probability of B given AR into probability of AR. Here in the last slide we have seen that this is the probability of A, but in here this is the whole probability, this is the probability of B, but it is nothing but summation of probability of B given AR into probability of AR, because already I have told that this is the probability, total probability of the data taking into account all possible event. For example, we will see the one more example. The three publishers supply books to the store. So 60% of the stock comes from the publisher 1 in that store, particular store, 30% from the publisher 2 and 10% from the publisher 3. So out of these, the 10% of the books from publisher 1 are faulty. 5% from the publisher 2 are faulty. 15% of the books from the publisher 3 are faulty. And my question is, what is the probability that a faulty book comes from the publisher 3? So before solving this example, I will define the some event, that is, I will define the event B, which is that event that a book is a faulty. And AI event that the book comes from publisher I. Means if I consider A1, that means that event, that book comes from publisher 1. A2 is the book comes from the publisher 2, and A3 book comes from publisher 3. Is that clear? These are the only two events I have to simply define. So I'll just solve this problem, which is just by using your Venn diagram. So here the books comes from that first publisher, second publisher and third publisher. So I have to in that the store the 60% stocks from the publisher 1, 30% from publisher 2 and 10% for publisher 3. These are the some basic data given in the okay. So this is the just three publishers and respect to your probability. That means here your probability of A1 is 0.6, probability of A2 is 0.3 and probability of A3 is 0.1. Further, we have given that the 10% of the books from publisher 1 are faulty. So here we can see that the 0.1 B is even that book is faulty. So the A1 to B, that is the 0.1, and A1 to B complement. B complement means book is not faulty. Book is good. So this is the B complement other than B event. So that probability is 0.9. Similarly, 5% from the publisher to the book is faulty. So that means 0.05 the probability of B given that the event A2 means probability of B given A2 is 0.05, probability of B given A1 is 0.1. Similarly, probability of B complement given A2, that second publisher, the probability that book not faulty is 0.95. Similarly, probability of B given A3, that means book is faulty and the book is come from, given that book is come from the publisher 3 is 0.15 because 15% from the publisher 3 books are faulty. Similarly, probability of B complement given A3, that means book not faulty given that the book is come from the publisher 3 is 0.85. So is that clear that all these probabilities are clear from your side? So what we have to find that the probability that faulty book comes from publisher 3. Faulty book comes from publisher 3. So what you have to give on that book is faulty. That means probability of third publisher na A3 given B. We have known that B given A3, but what we have to find? A3 given B. Probability of A3 given B. So from Bayes theorem, that means we have to say that from the Bayes theorem, what we are going to find the probability of B3 and A divided by probability of A3 and B divided by probability of B. So your probability of B in the all probability of B, what is this? What is the probability of B? The 0.6 multiplied by 0.1 plus 0.3 multiplied by 0.05 plus 0.1 multiplied by 0.15. These are the probability. So when you have to find out this, we get this denominator, which is the summation. In the last slide, we have to see that the here this is the summation of probability of B given AR into probability of AR. So what is the probability of B given A1 into probability of A1, probability of B given A2 into probability of A2, probability of B given A3 into probability of A3. So using this formula, we can find out this. So 0.6 multiplied by 0.1, 0.3 multiplied by 0.05, 0.1 multiplied by 0.15, and addition of this we get 0.09. That is the denominator of your Bayes theorem. Now numerator. So what is the numerator is? Probability of A3 given B multiplied by probability of A3. Probability of B given A3 multiplied by probability of A3. So probability of B given A3 is 0.15 and probability of A3 is 0.1. So 0.15 multiplied by 0.1, 0.015 and divided by your 0.09. Once again I have told you that how to find the 0.09. The 0.6 multiplied by 0.1, 0.06, 0.3 multiplied by 0.05, that means 0.015, and 0.1 multiplied by 0.15, 0.015, 0.015 and 0.015, 0.03 and 0.06, that means 0.09. This is the your denominator value, and numerator value is 0.15 multiplied by 0.1, that is 0.015 divided by 0.09. We get the answer 0.167. Is that clear? That means कि publisher 3 supplies only 10% of the books to the particular store. Nearly 17% of the faulty books come from that publisher. Is that clear? Means that 17% books, faulty books come from the publisher 3. Actually, it means whatever. If we have to uh, supply the 10% book, means suppose 100 books are come to that particular store, so out of 100, 10 books are come from the publisher 3, but out of this 10, 17% means almost 2 books are faulty out of that 10 books. This is the just the meaning of this answer, that is the probability. So this is your the solution of this problem by using the base theorem. You can solve other problem by using the same uh, uh, the same concept. You can solve the problem. For your homework, I can just same problem. I will just ask you the try to your if you have to try to solve the what are the probability that faulty books come from the each of the other publisher. Means what is the probability that faulty book comes from the publisher 2? What is the probability that faulty book comes from the publisher 1? You can solve in your uh, own. Try to solve this. Very simple. Already you know the denominator part. This is the 0.05. You just only your probability of A2 given B or probability of A1 given B. These probabilities you have to find out. Try to solve this and practice on this topic. So and in next lecture we will try we will see the prior and posterior distribution and how it works, how uh, uh, it's already we have seen this lecture the prior and posterior, but what is the prior, what is the posterior, and how it works in the Bayesian inference, it will be seen in the next lecture. So thank you so much.